Okay, for question 23, we are given that this right here is the reciprocal function, and we're supposed to go backwards and figure out what the original function was. Okay, with a little bit here, another little comment here. This is going to be a over f of x. Okay, so there's also an a value here that I'm going to need to figure out here. Now, this is actually not as bad as we might at first think here. When you take a good look at this graph here, notice it seems to have an asymptote here, a single asymptote, which suggests to me at this point that this is likely a linear graph. And if you look at it and you compare this to our notes here, all of our linear reciprocals looked like this. So that's a pretty fair guess. This has got a problem here at x equals -3, okay? Which means what I've got here is I've got some sort of reciprocal function that has got a problem here at x equals -3. Okay, so that suggests to me that the denominator is going to be x plus 3. And just think about this for a second. If x equals -3 is our non-permissible, it stands to reason that, you know, if you plug -3 into this, you're going to get 0 here. So there we go. So this is the structure of this. Now what I need to do is find one more point on the graph. This is just like we did at the very beginning of the course with quadratics. Find one more point. Now notice I've got the point -2, 1 on my graph. If I plug that into my graph right now, my equation, 1 equals a over -2 plus 3. So I plug it in for the x and the y. -2 plus 3 is equal to 1. So a is equal to 1. Therefore, the graph of the equation of the reciprocal here is 1 over x plus 3. So if I want to know what the original function was, all I got to do is flip that, and that becomes y equals x plus 3. I simply reciprocate it back. You do that one more time, and it spits out the original function.